Hello, geometry folks. We are going to get started on our very first flipped video when you are at home. So we are going to need our second word chart today. You filled out the first one in class, and we're actually going to be filling out the last word in that first word chart, and then use something to write with, whether it's a pen, pencil, if you want a highlighter, you can do that as well. And then when we're done with the notes, you can put it back in your notebook or glue it or tape it. With that, let's get started. So starting with that first word, bisector, that we had from our last foldable, it's our last word in our first foldable. Bisector means to cut something into two congruent halves. And remember, congruent means to have the same measure. So if we look at our first diagram here, we have this line segment AB. And what's cutting the line segment AB is the line CD, and it's cutting it completely in half at this point M. So how we would read that is line CD, notice the notation, the line above the letters CD, is a segment bisector of the line segment AB. Remember, we say line segment when we see the bar above two letters. So that means that line segment AM is congruent to line segment MB, and AM is equal to MB, which means the measure of AM is equal to the measure of MB. So this diagram on the left is an example of a bisector or a line bisector, and we can also have a bisector or a bisector that cuts an angle in half. So here we have this big angle, angle CAD, and the ray AB is the angle bisector because we have this two hash marks of our angle, which means that this is congruent to this. So we have ray AB is an angle bisector, and that's how we would read that. Speaking of angles, our next word is angle, and an angle is two rays joined at a common point, which is called the vertex. So in our diagram here, our vertex or our common point is this B, and then how we can read this angle is one of three ways. So here we see the first way is we can say angle ABC, and you'll notice that this little half crooked L symbol means angle. So that's how we read this symbol right here, angle ABC. So that's if we're going from left to right. If we wanted to read it from right to left, which is totally legit for angles, we would read it as angle CBA, or we can just label it at its vertex, angle B. So all three of those are very appropriate ways to label an angle. And remember that from what you've learned from previous grades is that we can have acute angles, obtuse angles, and right angles, and we will talk more about that in class. Another type of angle is an adjacent angle or adjacent angles, and these are angles that share a common vertex and side. You guys, adjacent literally means next to each other, so I think you'll see what I mean when we look at this diagram. So just as this statement says right here, angle QRS is adjacent to angle SRT because these two angles share a common ray, ray RS, or they share the vertex R and the side, which is this ray, ray RS. So these two angles would be considered adjacent, this QRS angle and this SRT. Okay, so a specific type or a special type of adjacent angles is also known as a linear pair. And a linear pair are two adjacent angles that form a line. And you can see in our diagram here, here is the straight line. And in this diagram, we actually labeled the two angles with numbers, which is also something that we can do. And angle 1 and angle 2 are a linear pair because they are adjacent. They share this common ray right here, and then they also form a very straight line. And so that constitutes them to be a linear pair. Another type of angle is a vertical angle or vertical angles, and these are two congruent angles that are across from each other in what is called an X-like formation. So if you see the diagram here, we have two lines that are intersecting each other, and these black lines make what looks like to be a big X. And we have our angles here labeled angle 3, 4, 5, and 6. So angle 3 is across from angle 6 and vice versa. So this makes angle 3 and angle 6 vertical angles, and angle 4 is across from angle 5, and this makes angle 4 and angle 5 vertical angles as well. So here in geometry, vertical for our angles does not mean up and down necessarily. It means across from one another. So I guess you could think that it was up and down for 4 and 5, but for 3 and 6, it is definitely across. So just some little notation on that. Our next set of angles are known to be complementary angles, or two angles whose measures add to 90 degrees. And this may be a little bit of review for you. You might have heard about complementary angles before. So two angles whose measures add up to 90 degrees. In our diagram, we have a little red box here in the angle, and that is how we denote a right angle or a 90-degree angle. And here we can see that our first angle, angle 1, is 68 degrees. So if we really wanted to try to find the measure of angle 2, all we would have to do is take 90, subtract 68. Supplementary angles are two angles whose measures add to 180 degrees. So we can see in our diagram here that we have angle 4 and angle 3, and these two are a linear pair because they are adjacent and they form a line. And we can also see that the measure of angle 4 is 56 degrees. And knowing that our definition of supplementary angles, all we would have to do yet again is a simple subtraction of 180 minus 56 to find our measure of angle 3. So something to note also with this is that if we have two angles whose measures add to 180 degrees, that is also the degree of a line, because we just said that these two are forming a linear pair. So keep that in mind, that supplementary angles add up to 180 degrees, which is also known as a line. Next is intersection, and you guys, this is pretty simple. To intersect means to cross. So if you just think about a traffic intersection or a street intersection, that's basically the same thing in our geometry diagrams, but we also have another little more technical definition for our geometric purposes, and that is an intersection is the set of points geometric figures have in common. So in our examples, you can see here that these two lines, line M and line N, have a common point of intersection. They just have one point in common, which happens to be point A. Down here we have a plane and a line going through the plane. This line HE intersects the plane at point E, again at a single point. We could also say that even the line HE intersects the line DF on the plane. If we look over on the right-hand corner, we have two planes. We have a red plane or a pink plane and a blue plane. And when two planes intersect each other, we have a set of points, which is a line, like you can see here, this line Q. So just keep that in mind, that an intersection is the set of points geometric figures have in common. It may just be more than one point. This may be a new vocab word for you, skew. And skew lines are non-coplanar lines that do not intersect. So we'll look at what that means when we see the diagram. So take, for instance, this box or this cube. Let's first look at the line CD over here on the top right-hand corner or edge of this cube. So this is on one plane on the right-hand side of the cube, right? And now let's look at the line BF. This is on a completely different plane. This one's going up and down, and essentially CD is going away from you and towards you. So these lines, even though they're written on 2D, it looks like they would cross each other on a sheet of paper. We have to think about how In a 3D setting, these would be nowhere touching because this one would be going up and down to the sky and through the floor, through the earth essentially, and then this one would be running forward and backward. Those lines are on two completely different planes, and that's what non-coplanar means, not on the same plane. So we'll look a little bit more at coplanar and what that means and what non-coplanar means, but if you have questions on skew lines, I know that's a little hard for you to grasp right now, but we're moving into some deeper geometry, so we're going to get 3D here in geometry this year. Alrighty, ladies and gentlemen, we are on our last two vocabulary words for this video. So the first of the last two are collinear points. And the definition of those are points that are on the same line. So if we just think about parts of a word, co means together. Linear, there's a line written in here, right? And points. So points that are on the same line or points that are together. So let's look at this diagram. We have points A, B, C, and E all on this one line, and D is not. So that would make points A, B, C, and E collinear, and D would not be collinear. So hopefully that makes a little bit of sense and it's somewhat intuitive. So now let's take that same concept of collinear and apply it to coplanar. Coplanar are things that are on the same plane. Remember we said things because think back to our definition of a plane. We can have points or lines or rays on a plane. So we can have multiple things on a plane. So these are things on the same plane. So remember co means together, and then if we look at planar, that has the part of the word of plane in it, so we can think of those things being added together. Mostly coplanar points are what you'll see in geometry, but you can also have lines, rays, etc., like I said before. So if we look at this blue plane, we have points G, D, E, and F that are coplanar. We have G is coplanar to the line D, F, G is coplanar to the point E. We have so many different options. And again, this may be a little harder to conceptualize just because you probably haven't heard of planes all that much, but we will work with these vocabulary words more this week when you get back from watching this video. So with that, I cannot wait to see you guys tomorrow, and I hope you have a good night. Peace out.